2 radians, 6, the formula from our notes. 12A we know lies in quadrant 4, and 12B lies in quadrant 2. Of course they gave extra explanation, but 12A is quadrant 4, B is quadrant 2. 16, sample answers. Isn't it nicer when we know it's like all right, all wrong? Well, it's only a sample answer because how else could you have gotten a coterminal angle? What else could you have added besides 2 pi? Yeah, 4 pi, 6 pi, 8 pi. Thanks, Wesley. Could have added any multiple of 2 pi. You could have been a real stinker and gone to like 56 pi and then made me work for it. But the easiest one was 2 pi. But they said positive and negative, so you had to add and subtract. The easiest ones are adding and subtracting 2 pi. Whoa. Whoa, whoa, whoa. They changed the process down here, right? What happened when you added 2 pi? Did you get a positive angle? So that was a negative. That was one of the answers. You didn't want to subtract because if you subtracted, you'd have 2 negatives. They wanted one of each. So hence why 1 second they added 2 pi, and then they added another 2 pi to this one, aka 4 pi to the original one. But those are sample answers. Does anybody have one they think is right, but they want me to check? Besides these ones? Okay. 28, A and B, did you guys sketch it correctly? Double check me. I think there are a couple typos right here in the beginning of chapter 4. So if something doesn't look right, because you guys write the questions, let me know, okay? Negative 30 is in the 4th quadrant. Negative 750, we had to twirl how many times? Twice? Good, because that's 720 and then go another 30. 32 I have the complement as 44, the supplement as 134. They made it nice and easy on you, had degrees. But why in letter B was there no complement? Good. Complements are what's left over to get up to an angle. If you pass an angle, there's no complement. You can't have negative complements, only positive, only adding up to. If it goes past, all deals off. 38, you were converting from radians to degrees. Hopefully you built the bridge the right way. 38 was nice and easy because the pi's cancel out, so you get to go ahead and reduce, and there you got your degree. The pi's cancel out. But not every time will the pi's cancel out. This one, just this, the original radian answer, the 7 pi over 12 had a pi. Sometimes they stay. Number 44, also converting, building the bridge. There we go. This one wasn't nice and pretty. Some of you guys might have gone to decimals. Some of you might have left it as a fraction. I wouldn't have minded either way. 52 was a plug and chug to the formula. Except, what? I don't get it. Theta is an angle. Don't we just plug in 150? What did they do? Why were they multiplying by a bridge? Get rid of what you don't want because every physics formula, every one of those arc lengthy ones from homework had to have the angles in radians. So if you guys tried to put the angle in degree, we talked about it on Friday, did examples on Friday, all of those formulas at the end applying radians needed radians. It's built on arc length, and arc length is distance around, which is a radian. Degree, remember that awkward little tick mark on the protractor. Radian is a radius around. Radius around. Forgot I did that with the cup and the patty paper. Number 76 is the last one. Number 76 is the last one. Arc length must be increasing. That one might have been a little confusing for you guys to visualize. We can go to it really quickly. Oh, did no one stop me on that? Your question had nothing to do with arc length, right? What was your question? Awkward, you're supposed to write down the question.
Which unit is greater?
Which measure? Yeah, which measure is greater, right? A degree or a radian? And what'd you guys all answer, hopefully?
Neither.
Oh, why is a radian bigger? Yeah.
Because
It takes up more of the angle. And Matthew, what were you going to say? Yeah. Remember in the example they were working on up here? Wasn't this a radian? Wasn't that a distance around the circle? And that distance around the circle, if we were to start in standard position and start going, was about like 60-ish degrees. How do I know that? Because it takes about 3 of these to get halfway around, 3.1415926 to be exact, right? Okay. This little 1 radian had about 60 degrees, so who's bigger? Does that make sense? The radian, or the degrees are tiny, tiny, tiny. What's bigger? The radian. The radian has like 60 of the other ones. Yeah, so 1 radian is bigger than 1 degree, for sure, for sure. But it was a tricky question, because if you guys aren't totally solid on degrees versus radians, you're like, I don't get it. They both measure angles. Yeah, but 1 degree is this. 1 radian is that. Radian's bigger. Number 76, sorry. Was there another typo? I thought there were 2 this section. The rest of them all matched up with what you guys wrote down? You sure? 76 was like a totally different question. I need to just put a line through that, then I won't forget next year. Insert. Can I insert a line? Okay, that way I know to go looking for it next year. All right, if you guys are sure. Any questions that you have on homework? I could have sworn there was 1 more typo, but maybe not. Anything else? Yeah. Okay, let's check it out as to what it is. 38B, right, Tyler? Let me see. Tyler, you're my hero. It was a totally different problem than the answer key showed. How did no one else catch that? Are you guys even awake? Okay, pause. Pause. Okay, you guys all marked it wrong and put -420. A, where's your confidence? And B, where's your go back and look and see that this is not even the same thing you wrote down? Especially when I was begging for typos because I thought there was 1 more.
Like, we glanced at it for like 5 seconds and then you kept going.
But I talked about the bridge, so there was time. Oh, if you were following along with me. I got it. If you were following along with me, then you would have just skipped over it fast. All right, let me cross all that out. That way I remember for next year, and the poor pre-cal kids that are half asleep on a Monday morning won't have to remember or find the mistake. Thanks, Tyler. You're my hero. So the actual example was 5 pi over 4. But you still multiply by the same bridge, right?
Yeah.
So the bridge would have been 180 over pi. Pi's cancel out. Did anybody figure out every time what 4 and 180 always reduces to? What's 1/4 of 180? How do I know it's 45 really quickly? 90 is half. Good. So what's 1/4? 45. But in my brain, actually, to be honest, I would much rather just go by pi over 4s. 1 pi over 4, 2, 3, 4 pi over 4. Even 5 pi over 4, than having to figure out what all the like 45s are. 45, 90, 135, 180, 225. Ugh. I don't like degrees. It's nasty. It's too much numbers. This is way easier. It's just 1 1/4. Ha-ha! There he is. Anyway, but they asked us degrees, so therefore 5 45s would end up being 225. But you that like degrees, wasn't that harder than just doing 1/4?
Yeah.
That's what I thought. All right. Fractions aren't as scary as we make them. Thanks, Tyler. Anything else that we need to go over? I think that was just the 2 typos. It's only if you have any other questions. Okay. Patty paper time. You guys ready? I want you guys to, with your patty papers.
Wait, did you say we were going to write something on our notes? From a question?
How did no one ask me about degrees, minutes, seconds?
I'm just extremely overwhelmed. That's what happened on Monday.
I just closed the book too. Where were the degrees, minutes, seconds in your homework, guys? The little slash marks? Yeah, there you go. See, here's the dilemma. If we're supposed to go over questions you have on homework, problems you didn't get, you kind of have to tell me what they are, or else I kind of can't go over them. True? Okay. So I did say when we get there in homework, we'll go over it. The problem is no one ever got there because I gave you odds for them and no one ever asked me about it. Well, that's a dilemma. So thanks for those of you guys that were like, hey, I care enough because you said there was something in notes. But I don't think in notes it said literally degrees, minutes, seconds. Or if it did, I should say in the homework. If it did, it must not have really stood out to you guys very much, huh? I apologize for some reason. Do you see? Huh. Come on. Huh. Well, my toolbar is missing in this file, but that's okay. We'll just keep going. Did you guys just have 49? Ah, there were 2 whole questions and no one asked. Okay. How'd you guys do this? What, Matthew? Oh, I meant no one had a question on it, so I'm just curious how you got it done. So how'd you do it? You teach me. How? You have it right there in your homework. So how'd you guys do 47?
I checked Google for how to convert those things.
Multiply by 6 over 2? No. 6 over 10? Nope. Tyler. Okay, what kind of decimal? Like 0.45? Plus 45? You can do plus. But you can't just do plus 45, because that would be like 99. What about 60? So it has something to do with 60, that's right.
Yeah, 45 over 60. 45 over 60.
Oh, 45 60th, like that? Okay, so then you get a decimal from that fraction, right? And then you can say 54 point, and what did you guys get? 775. Okay. So y over 60. Ah, this is why you want your notes open. So what are these little things called? Well, degrees we know. It's a little degree mark. Minutes, that's a little single slash mark that we just saw in 47. It's the very end of 4.1. When you guys go into 4.1, I talk about degrees versus radians. But then as you're doing homework in 4.1, it's like, wait, there's something else besides degrees? Yeah, there are minutes and seconds, which are partial degrees. And we'll talk about in just 1 second why they're necessary, why they're important. But degrees, minutes, seconds. So when you go into 4.1, I just want you thinking degrees versus radians. But then as you go through homework, all of a sudden there are these weird little slash mark thingamabobs. And some of you went and looked at examples and figured out I can convert because 1 degree is equal to 60 minutes, which is equal to 3,600 seconds. Because 1 second is 1/60th of a minute, which is 1/3600th of a degree. And 1 minute is 1/60th of a degree. Now, that just gets confusing after a while. The units for degrees, minutes, seconds, degrees we already know, minutes is a single slash, seconds is a little double slash. The long story short is if we're trying to build bridges, we can use any of these relationships. 1 degree gets cut into 60 pieces, and each of those pieces is called a minute. And 1 minute is cut into 60 pieces, and each of those 60 pieces is called a second. Just like time. Except instead of hour, it's degree. So that could be a way of remembering minutes and seconds in the sense of, oh, go by 60s, like you would from hours to minutes to seconds. So if you're trying to convert to decimals, some sort of A degrees plus B minutes. Actually, they won't put a plus. That's something that you're going to have to figure out. B minutes and C seconds. We can do what you guys just did. And you said, hey, keep the degrees, they're good. Add B over 60, which is going to end up basically building a bridge. Because you could do B minutes times, 60 minutes in 1 degree. And that would get rid of minutes, and we would end up with B over 60 degrees. And C seconds. minutes in 1 degree. We could ultimately get rid of our seconds and our. We could just go straight to 1 over 3600th. And that's what you guys kind of were doing in 47. You just didn't have seconds. If you did, you could have kept going. Or you could go the other direction also. You could go ahead and take some sort of nasty, this is probably going to be better with an example. If we had something like 12.452 degrees. We could go ahead and say, hey, that's 12 degrees. But how many minutes? Well, we could take the fractional degree and say, what if we were to change you to, well, hold on, we'd have to do degrees on bottom, minutes on top. We'd have to do degrees on bottom, minutes on top. Still building bridges, basically, right? Getting rid of what we don't want. But we have to take our decimal of, what is it, 0.452? You guys can double check me, make sure I'm right. When I get 27.12? Okay. Now, why if I was to get 27.12? The degrees have canceled, just like the seconds canceled. So I was left with my minute mark. Why am I only going to write 27 minutes, and I'm going to keep going again? Good, a fractional minute can be written in a different unit. All you do is build another bridge and say, oh, hey, there are, nope. 1 minute has 60 seconds. And that would be the lowest I could go as far as the smallest unit I could go into, and double check me when I get 7.2. A smaller measurement than a second, so I go ahead and just say 7.2 seconds. We don't usually go into that, and here's the reason why. Degrees, minutes, seconds. Well, the only practical application, or I should say in my mind, the only practical application is, oh wait. Did anybody think it sounded weird when I said something about cutting a degree into smaller units? Didn't we just talk about what's bigger, a radian or a degree? And if we're talking about what's bigger, a radian or a degree, actually I think I want to go over on this side. Who was bigger and why? The radian was bigger. Why? Oh, that's 2 degrees. I was mean. Why is it so hard for me to get 1 degree? Why is it so hard to get 1 degree? Because it's so tiny. Why on earth would we ever cut that into 60 pieces? And then cut each of those 60 pieces into 60 more pieces. Pause. What happens when I make this angle bigger?
It's still 1 degree.
It's still 1 degree, but what happens to the distance between?
They expand.
Is there anything practical being measured in degrees that's a whole lot bigger than that? Even bigger than that.
Like,
Coordinates, GPS, latitudes and longitudes. If you were on the North Pole and you had 2 protractors together, aka 360 degrees, and you were in standard position, which would be, well, that's awkward. What's due east from the North Pole? Anyway, let's just say that you wrote an XY axis. You're facing the 0. Cool. And I said turn 1 degree. What would you do? On the equator, and I told you to go 1 degree. Okay, let's say you were stuck in the ocean somewhere and you wanted to tell someone where you were. Do you just want to tell them in degrees? No, because then you just have this huge cross-section of the latitudes, longitudes, like, well, I'm in there somewhere, and there's sharks, can you come get me right now? You needed to be more precise. So, do we need to cut this degree on our paper into minutes and seconds? No. But if it's applied to GPS and navigation, do we want it as precise as possible? Yes. As strong? Oh, astronomy. Yeah. I was just keeping it with like our globe and with latitudes and longitudes, but there are degrees that are projected out into space we need. Yeah, if you were trying to locate, well, you know how like some people, the really sappy people, just kidding, I mean, maybe it's romantic, like name a star after someone, and you're trying to find your star on the star chart, and you have to actually think about like the location, and the location has degrees, but if it's just degrees, that's a huge space of sky. So anyway, Joe, astronomy, good job. But also GPS navigation. Long story short, is a degree always small?
No.
No, a degree can be huge. But what would still always be bigger of whatever you're measuring? A radian. Okay, section 4.2, thanks Jason for keeping me honest, but we need to go ahead and get notes ready and then figure out what the patty papers are for. Good thing is, you're already in notes, right? Good thing is, you're already in notes. So, section 4.2, the unit circle. We'll get back to it in 1 second as far as the patty papers. We'll get back to the patty papers in 1 second. After you guys get down these pages of notes. You don't need to skip any lines. I am going to zoom on that table in just a second, but I want you to get the first page down. If you want, which it might be a little too late for some of you that are doing it, you could use this to trace a circle, right where that is, if you want. But there is going to be another place, so you could also use the cups. You can make this one small if you want. But when I tell you to use a cup, share with your group, pass it around real quick. What? Equation of a circle, x squared plus y squared is, you guys remember? R squared. This one's centered at the origin, 0, 0, because our circle is centered at the origin. And remember, x, y are just coordinates, is just a coordinate, right? X, y is just a coordinate. How far over you go, how far up you go. Huh, interesting. How far over, how far up makes a triangle. The hypotenuse could be the radius because it's the distance from the center to the outer edge. Unit means make the radius equal to 1. So we're actually going to take away the r and put in a 1. 1 squared is just 1. So the equation of the unit circle is scaling back any circle to a radius of 1. Has something to do with geometry and similar triangles. We'll see it in section 4.3, but for right now, we're not so much worried about the size of the circle. The 1 just makes it kind of easier for us to visualize. What we're worried about are the trigonometric ratios. Not sin and cos and tan, but sine and cosine and tangent. When younger kids get their calculator and look at the buttons, they're like, sin, what? At least so asked someone in Algebra 1 a couple years ago. Okay, now we're not going to go in way more depth on the circle itself, but we are going to instead zoom in on what's going on the next page. Because the next page says, okay, so we have this ordered pair on a circle, whatever, with a radius of 1, whatever. What's the big deal? Well, the big deal are the ratios. Oh, we didn't have it yet? Coordinate points, aka the x's and the y's, relate to trigonometric ratios. And the table that I have kind of selected on the next page, I'm going to zoom in on, show those trigonometric ratios and how they relate. Trigonometric. But just think trig, and trig is right triangle. It's dealing with a right triangle. Ratios, that's just like making fractions out of different parts. So we're taking the sides of a right triangle and making fractions out of them. Well, non-right triangles, we're not going to be able to use trig. I know the silly stool keeps on getting in my way. Non-right triangles, we're going to have to use things like law of cosines and law of sines. That's still dependent on trig, but aren't just outright using it. Okay, I can zoom in now, yeah? To make life a little bit easier, if you guys want, you don't have to use t. You don't have to use t. You could use thetas. We've been using thetas for angles. I don't mind that. You could do like sine of theta, cosine of theta, secant of theta, cosine of theta, of theta. But whenever you have an x, y on a unit circle, like I just showed you, a random point, I just chose one. I showed the over and up, which actually formed a right triangle. Sine is always going to be the y of that coordinate. Cosine is always going to be the x. Tangent is always going to be the y over the x. Cosecant is going to be the reciprocal of the sine, 1 over y. As long as y is not 0. Because if y is 0, that kind of answers the question down here. Because both cosecant and cotangent both have denominators of y. And so if the y's are 0, then each of those are undefined. And if the y's are 0, that's the same thing as the cosine of the theta equaling 0. So cosecant and cotangent both, sorry, the y, that's sine. I was filling in the top one in my head. Sine is the y value. So when y is 0, which will also be the exact same place as when sine is equal to 0. And as you guys noticed, secant, and maybe you also noticed tangent, both have denominators of x, so they're going to be, secant and tangent will be undefined. When x is equal to 0, same thing as saying when cosine is equal to 0. Now once you guys have this page written down, this table written down, whether or not you've used the cup yet to trace a circle, whether or not you've yet used the cup to trace a circle, go ahead and trace a circle, a nice big one with the cup underneath this last little note. And label it unit circle. Don't do anything else to it, but label it unit circle. Go ahead and draw with the cup. Go ahead and draw with the cup a circle in your notes. Now, once you draw on your notes a circle, I want you guys to go ahead and get your patty papers, and I want you to draw a circle on your patty papers as well. Now, the patty paper, I don't want you to do anything to it yet. If I had you find the center of the patty paper, that might end up being the center of your circle, and that might not end up being the center of your circle. So I want you to try to center it, just eyeball as best you can on the patty paper. Don't fold anything yet, though, or else we won't be precise. So go ahead and trace a circle on your patty paper. And ultimately, we're going to be gluing this in on top of the circle that you did in your notes. Ultimately, we're going to be gluing this in and on top of the circle in your notes, just not yet. I'm trying to get you guys to think in radians, right? Radians are really just fractions. And some of you are so terrified of fractions. Yeah. So go ahead and get your cup. And then draw the circle as best you can, centered on the paper, but not folding the paper yet. On the patty paper. No, in the notes too. We're going to eventually tape this on top of the space in your notes. So you just set aside space in your notes for where this is going to go, okay? You can always trim it if you need to. Okay. Once you have the circle on your patty paper, now I want you to find the center of the circle. And to find the center of the circle, I want you to fold into half circles, into calzones, aka into pies. And then I want you to fold into half calzones, aka half pies, aka quarter circles. So you should be able to see the circle through the patty paper, right? You're going to fold it to where the centers, or I should say, to where the halves meet. Make that fold. You can go ahead and trace that line. Then you're going to fold the other direction. So you should have, in a sense, your xy axis, and you should have your 0, 90, 180, 270, 360 if you fold it properly. You'll have also found the center of your circle, right? Okay, go ahead and unfold and trace those lines. If you want to grab out a student ID card, a ruler, some flat edge, use your notes, you can do that as well. But with the folds, most of us can kind of follow the folds also and get it what we need it to be. So go ahead and trace those axes. You're folding it into 90s, so fold it down and then across. Does that make sense? You should have also found the center of your circle, true? Okay. We talked about how pi is a calzone, right? So standard position starts right here at 0. If we go the half circle, over here would be pi, and if we put another half together, we would have 2 pi, true? Okay. No, right now, just those. Just those. But guys, if this is your calzone, then how much of your calzone is if we folded it in half again? How much of a calzone? Half of a calzone. Right? If a calzone is a semicircle, then if we fold it right here, isn't that a half calzone? Right? AKA 90 degrees. It's just half pi. Just half the calzone. So if we count by halves, if you unfold it, we could go 0, we could go 1 half, we could go 2 halves, we could go 3 halves, aka 3 pi over 2, and then 4. It's right back to 2 pi. Tyler, what's up, kiddo? Write it on the patty paper, and this is going to be taped into your notes. Does that make sense? Now, if the radius of the unit circle is 1, then can't we make this point 1, 0, because it goes over 1 up 0? Can't we make this is 1, can't we make it 0, 1? So what would this point over at pi be? Negative 1, 0. And then down here we have the point. Almost everything we do in Precalc you need to learn and be able to use and be able to remember. Don't worry, I'll give you plenty of notice. It's not tomorrow in any way, shape, or form. It's actually after section 4.4. Okay, now if we take pi over 2, right? If you go back to your 90, what happens if we fold this in half? Joe, what happens if we fold this in half? So we could take our 90 degrees, we could fold that in half. Now we're not going to go in half again, because half of 45 is 22.5. That's nothing special in geometry. We like 45s, 30s, and 60s. So just take your 90 and cut it in half. Tomorrow we'll do 30s and 60s. Today we'll end with 45s. You guys could trace those lines, right? If you fold it in half, that would be 45s. But my question is, how much of the calzone is that? A whole calzone is a half. 90 degrees is a half a calzone. Well, wouldn't this be a fourth of a calzone? So couldn't I go ahead and then say that this is going to be 1/4 of my pi? 2/4. What would this be? 3/4. It's okay, kiddo. You can get a new one tomorrow. We just don't have time today. This would be 4/4, then 5/4, 4/4, then 7/4. In radians, we're really just counting by fractions. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Just the ones in between, the even fourths got reduced. And from geometry, with a little bit of work that we'll see in the triangle section of 4.3, we could pretty quickly figure out the ratios are square root of 2 over 2 and square root of 2 over 2. We're just going to have to talk about tomorrow how if you're in the second quadrant, the x's go negative and the y's go positive. In the third quadrant, the x's go negative, like any point would, and so do the y's. And in the fourth quadrant, the x's are positive and the y's are negative. Guys, we're building up your understanding of what this circle is, what it shows. Please tuck it in somewhere nice and safe. This homework isn't due until Wednesday. We'll finish up this circle and use it tomorrow. Sound good? Lauren, if you want, you can grab an extra one on the way out, kiddo. I know, I saw. There was a pile at the front, Joe, where it should have been turned in. Bye, guys.